Hello everyone, we are just continuing notes from section 7.1. Again, the confidence interval of the mean for when the population standard deviation is known. So we went over yesterday the difference between a point estimate and an interval estimate. So here's the formula we're going to use for an interval, a confidence interval. So we're going to take the mean and we're going to subtract. We're going to find a special z-score here. So we call this z sub alpha over 2. And I'll talk about the symbol alpha here in a second. We're going to multiply that by the standard deviation divided by the square root of the sample size. And our population mean is going to be between our mean minus this, what we're going to eventually call the margin of error, and then our mean plus this value, which is the margin of error. So that phrase like give or take, so that's what we're saying. Our sample mean is going to be give or take a couple values to give us this population mean. Or vice versa. Our population mean is going to be within these two values here. So this alpha, this is the total area in both tails of the standard normal distribution curve. So we're going to take a look, we're going to make a sketch of this for each of those three common confidence levels. So let's start with 90%. If we make a sketch of our standard normal distribution and we block off the tails, we want 90% to be in between. So we have this tail here and this tail here, which means alpha, so 90% is between these two values. Alpha would be 10%, but then alpha over 2 is going to be 5%. So that means this little area right here is representing 5%. That's our alpha over 2. And then over here we have 5%. So our z sub alpha over 2 is the boundary value. Z sub alpha over 2, even though this one's going to be negative, this one's going to be positive. Now, because we're adding and subtracting, we just need it to be positive anyway. So what we're going to do, go to our calculators. We just want to type into the left here. So we're going to go to menu 553 and just type in 0.05. And we should be getting a negative, but in this case, we'll just say z sub alpha over 2 for 90%. Z sub alpha over 2 is going to become a negative 1.64. Actually, I just said it. We'll leave it positive because we are going to end up adding and subtracting. So z sub alpha over 2 is just going to be a positive 1.64. Next, let's take a look at 95%. Again, as we sketch our standard normal distribution curve, 95% is going to be in the middle here. So just like up here, this was 90%. This is going to be the 95%. So that means alpha is 5% and alpha over 2 is 2.5%. So right here, this is 2.5%. And then right over here, this is 2.5%. So z sub alpha over 2, we just have to watch our decimals. Go back to menu 553. We have to type in a 0.025. And z sub alpha over 2 becomes a 1.96. Now what's nice is they're going to be this every single time. So if you just keep track, write these down, we don't have to keep finding them every single time. Let's do the third. Now again, we can do this for any confidence interval we're asked to, but these are the three most common. So let's do 99%. So again, that means 99% is going to be in the middle here, which means alpha is going to be 1%. Alpha over 2 is going to be 0.5%. So that means this little bit right here and right here, this is 0.5%. So our z sub alpha over 2, again, if we go back to menu 553, we need to type in a 0.005. and we should be getting a 2.58. So that's what we're going to use in our formula for this part right here, where it says minus e sub alpha over 2 and plus e sub alpha over 2. That's how we find them. Now again, if it's a problem involving 90, 95, or 99%, we just go back to these values. Now throughout this section and or this chapter rather, and even into next chapter, we're going to see these assumptions here. So the assumptions for finding confidence interval, we're to assume that the sample is a random sample, and we want to also assume that the data is normally distributed. So either n is greater than or equal to 30, or the population is normally distributed. So I explained the values we were adding and subtracting from our sample mean was called the margin of error. So yes, the calculation for the margin of error is equal to this z sub alpha over 2 times the value we get here is we divide the population standard deviation. That's why it has to be given to us in this section, divided by the square root of n. But the definition here, this is the maximum likely difference between the point estimate, which is the sample mean of a parameter, and the actual value of the parameter. So again, kind of showing this constructed in our standard normal distribution. Let's say we're looking at, again, this is where our population mean would be. And let's say we're looking at 95% in the middle. So we could even extend these. So we'd have 95% in the middle here. This portion right here and here, this is going to be the z sub alpha over 2 times population standard deviation divided by the square root of the sample size on either side. And again, this little portion over here, this is the alpha over 2, and likewise over here. So this could be interpreted as 95%. So this is the distribution of our sample means. So this means 95% of sample means will be within this error value on either side of the population mean. But again, all we really need to know is the formula that I gave you on the previous page. All right, let's take a look at the rounding rule for the confidence interval for a mean. All right, for population mean, where we're given raw data, just like all the other rounding rules, we round out to one more decimal place than the raw data. Now, if the sample mean is already given to us, we round to the same number of places as the sample mean is. So for the population mean, using sample means, because what it means is the rounding was already done for us. All right, so we're going to go through 3 examples. All right, our first example is just a straightforward calculation for different percentages here for confidence intervals. We want to find z sub alpha over 2 for the 92% confidence interval. So we'll do that first. So remember, first what we have to figure out, remember this is the area in between, so then the area left over is going to be 8%, but then we need alpha over 2 is going to be 4%. So that's what we type into our calculator. So again, we want to go menu 553, type in 0.04, and we should be getting, so we would write this as z sub alpha over 2. We just want the positive value of this. We should be getting a 1.75. You guys go ahead and try this for 96%. We don't necessarily need the sketch of the curve anymore. Pause the video to fill this out and then resume playing. So here this means alpha should equal 4%, which means alpha over 2 should equal 2%, and then z sub alpha over 2. And if we go to menu 553, type in 0.02, we should be getting a 2.05. All right, so now we're bringing this all together. This is going to be our first confidence interval we work through. So in this scenario, a researcher wishes to estimate the number of days it takes an automobile dealer to sell a Chevy Aveo. A sample of 50 cars had a mean time on the dealer's lot of 54 days. Assume the population standard deviation to be 6 days. Notice it says population standard deviation. Find the best point estimate of the population mean and the 95% confidence interval of the population mean. All right, to answer the first part, and I said this plenty of times yesterday, for part A, the best point estimate is what? The sample mean. So the sample mean is going to be 54. We would say 54 days. All right, for part B, we're going to take this 54. Now we just could go back to our notes. The 95%, that z sub alpha over 2 was not 1.96. So that means we're going to subtract 1.96 times, remember it's the population standard deviation 6 divided by the square root of our sample size. And mu is going to be in between this value and the value we get when we say 54 plus 1.96 times 6 over the square root of 50. Now this was not raw data. Notice our sample mean was given to just the nearest whole number, so that's what we're going to round everything to, the same place. So to the nearest whole number here. So just go ahead and calculate both sides of this and round to the nearest whole number. All right, so we should be getting that our population mean is between, we should be getting like a 52.3368. So we could just say this is 52. And for the other one, we're getting a 55.66, so then we're going to say 56. So that is our confidence interval. But we want to summarize this. So how we would write our answer to this is we could say one can say with 95% confidence, we could abbreviate, that the interval between 52, there's so many different ways we could phrase this, that the interval between 52 and 56 days does contain the population mean based on a sample of 50 cars. Or we could just stop it after does contain the population mean. You could also word this as one could be 95% confident that the population mean will be between 52 and 56 days. But we want to label this days because that's the context of the problem. All right, and we'll try one more. Here we have a survey of 30 emergency room patients found that the average waiting time for treatment was 174.3 minutes. Assuming that the population, here it is again, population standard deviation is 46.5 minutes, find the best point estimate of the population mean and the 99% confidence interval of the population mean. So again, part A, very easy. The point estimate is going to be what? The sample mean, that's right here, 174.3 minutes. For part B, we're going to start with that sample mean, 174.3. We're going to subtract 99% means we're working with that 2.58 times, we'll have 46.5 divided by the square root of 30. So our mu is going to be between that and 174.3 plus the margin of error. Now notice here everything is rounded out to, it's already found for us, so it's rounded out to the nearest tenth, so we're going to round to the nearest tenth. So go ahead and calculate that. All right, so as we round this, we should get that mu is between a 152.4 and then we should be getting a 196.2. All right, so we could say, or summarize this, one can say with 99% confidence that the interval between 152.4 and 196.2 minutes does contain the population mean. Or as I mentioned before, we could say, one can say with 99% confidence that the population mean will be between 152.4 and 196.2 minutes. All right, so just use the rest of class time to prepare for your test tomorrow. And then on Friday, I'll give you the worksheet. We'll start the worksheet over section 7.1.